An element is a substance that cannot be broken down into simpler substances by chemical means. Examples of elements include gold, silver, and oxygen. In contrast, a compound is a substance made up of two or more elements chemically combined in a fixed ratio. Examples of inorganic compounds include sodium chloride, NaCl, carbon dioxide, CO2, and calcium carbonate, CaCO3. These types of compounds are typically formed from non-living matter and do not contain carbon-hydrogen bonds. Inorganic compounds are important in many industrial processes and are essential for life in the form of minerals and other nutrients. Sure, here's another paragraph. Inorganic compounds can be classified into several categories based on their chemical properties and structures. For example, acids are compounds that release hydrogen ions, H+, when dissolved in water, while bases are compounds that release hydroxide ions, O, when dissolved in water. Salts are compounds formed from an acid and a base that combine to neutralize each other and produce a salt in water. Other types of inorganic compounds include oxides, which are compounds formed from a metal and oxygen, and halides, which are compounds formed from a halogen and a metal. These categories of inorganic compounds have a wide range of applications in fields such as medicine, agriculture, and manufacturing. Certainly, here's another paragraph. Inorganic chemistry is a branch of chemistry that focuses on the study of inorganic compounds and elements. It is concerned with understanding the behavior and properties of these substances, as well as their reactions with each other and with other types of compounds. Inorganic chemistry plays a crucial role in many areas of science and technology, such as materials science, environmental science, and biochemistry. Researchers in this field use a variety of techniques to study the properties and behavior of inorganic compounds, including spectroscopy, X-ray crystallography, and computational modeling. By understanding the fundamental properties of inorganic compounds, researchers can develop new materials, improve existing technologies, and gain insights into the workings of biological systems. Of course, here's another paragraph. One important area of inorganic chemistry is the study of transition metal complexes. These are compounds that contain a transition metal ion surrounded by a group of ligands, which are typically small molecules or ions that can bind to the metal ion. Transition metal complexes have a wide range of applications in fields such as catalysis, materials science, and medicine. Researchers in this area are interested in understanding how the structure of the ligands and the metal ion affect the properties and behavior of the complex. They also study the reactions that transition metal complexes undergo, such as oxidation-reduction reactions and ligand substitution reactions, which are important in many chemical processes. Certainly, here's another paragraph. Another important area of inorganic chemistry is the study of solid-state materials. Solid-state materials are materials that have a definite crystalline structure and are typically inorganic compounds or elements. Researchers in this field study the properties of solid-state materials, such as their electronic, magnetic, and optical properties, and how these properties are related to their structure. They also study how to synthesize new solid-state materials with desired properties for applications in electronics, energy storage, and other fields. Solid-state materials have a wide range of applications in modern technology, from computer chips to solar cells, and are essential to many aspects of our daily lives. Inorganic chemistry also plays a crucial role in environmental science. For example, researchers in this field study the behavior and fate of inorganic pollutants in the environment, such as heavy metals and pesticides. They also study how inorganic compounds can be used to remediate contaminated soils and water. In addition, Inorganic chemistry is important for understanding natural processes such as the geochemical cycles of elements,